afternoon. Today I'm talking about tree health in downtown Atlanta. Right now, ash trees in Georgia are dying by the millions because of this emerald ash borer. This insect has only been in the United States since 2002, but it has spread to 35 states. The Georgia Forestry Commission claims this beetle kills every single tree it lands on. To minimize the threat of the emerald ash borer, remote sensing is used to identify ash trees that are in different stages of infestation. And as you can see, my study area is City of Atlanta. Before I began my supervised and unsupervised classification, I enhanced the images with ArcGIS Tools to get higher resolution on the Landsat images. According to one of the articles I read, it is better to composite bands 1 through 7, then set the band combination to 4, 3, 2. This gave the image a sharp and smooth texture. For the unsupervised map, I used the ISO Cluster Unsupervised Classification tool, where sample points are assigned to clusters that are similar. And even though I was able to give Landsat 8 higher resolution, the unsupervised method remained inconclusive. For the supervised map, I used the Landsat 8 15 meter resolution again. However, this time I used the classification wizard tool with the object-based method NLCD schema with the random tree classifier. According to another article I read, it mentioned the object-based segmentation is better than the pixel-based because of how complicated tree canopies are, like the different shapes and reflectant values. For my third map, I used the NAPE 2015 3-band 0.5 meter imagery from USDA. I chose the NDVI because the second article I read performed a test to see which indices work the best in detecting beetle damage and tree health, and overall the NDVI was the most accurate. And finally, I created a LiDAR point cloud vector data map to check for canopy height. After subtracting the ground points from the canopy points, I used the raster calculator to get the canopy height. Overall, the outcome of this study was a success. Some of the remote sensing techniques used were able to locate and identify the health of the ash trees. Challenges included pixels with multiple classes, making it hard to classify, and the point data retrieve from ArcGIS portal did not have any information on times, date, or accuracy. Ground truth assessment will be needed if further study is done.